Hey guys, Mr. Chase here, and I'm out in my backyard, and I'm looking at this tree. I know we've been learning a lot about circles lately, and this is a tree that fell down. Actually, I had to cut it down in the middle of the winter. If I'm able to find the footage of when I chopped it down, I think in December, I'll insert that right here. So that was supposed to be me running around in the woods over here with my wife taping, and that's when this tree came crashing down. But I was watching another video, and hopefully you watched it yesterday, and it was about how to tell how old a tree is. Now they say you can count the rings, but this has all been blended. This is a little bit of sap that's come out, and obviously the bottom here, as you can tell, it kind of got ripped apart. So it's really tough for me to like count the rings. That's what they say you can do. But instead, if you watched the video yesterday, it said that you can measure the circumference of the tree, divide it by pi, find out what the diameter is, and then figure out what type of tree it is, and it'll tell you about how old. Okay, so I'm gonna try to do that, and I'm gonna encourage you guys to try that in a tree near you. If you're able to watch yesterday's video, we're gonna follow the same steps. So if you remember, the guy said get a measuring tape. Now, if you don't have a measuring tape, you can use a piece of string or ribbon, and then you can measure that out if you have a ruler or something like that. Okay, and he wanted to get a section of the tree. A section of the tree that's about 5 feet from the bottom. So I'm standing about 5 feet from where it fell. All right, maybe a little bit more, but it's all I got to work with. The rest of this brush is too hard to get into. So I'm gonna take this section right here, and I'm gonna do exactly what he said. I'm gonna measure around, okay? Remember, don't use your measuring tape and bend it that way. Bend it with the numbers on the inside. That's what he said from the video yesterday. Okay, I'm gonna measure around. I don't want this branch in there, so I'm gonna measure around. And let's see if I can get a pretty accurate measurement. Okay, it's about 46 inches. Okay, 46 inches around. All right, and here's what I'm gonna do. I'm gonna take that number, and I'm gonna go back inside, and I'm gonna continue the video. I'm gonna take that number, I'm gonna divide it by pi, right? Pi is gonna tell me, 46 divided by pi is gonna tell me how big the diameter is. I'll probably find out the radius as well by dividing that by 2, but I'll find the diameter of it, and then I have to look up the growth number, okay? If you remember from the video yesterday, this type of tree and all types of trees have growth numbers. So you find their diameter, and then you multiply it by its growth number, or growth rate number, I think that's what it was called, and that will tell you roughly how old this tree is. Now, I'm guessing this tree is 20 years or more, just because I was trying to measure by counting the rings. It might be way more than that, or I might be way off. Okay, all right. Actually, I'm gonna see if I can show you a picture as well of that growth rate sort of factors, right? If you have a coniferous tree, right? If you have an evergreen tree, you have to multiply it by a low number, okay, and so on and so forth, okay. But for now, I'm gonna go with the 46 number, 46 inches. I'm gonna take this inside. We're gonna do a little bit more. All right. See you in a minute, guys. Hey everybody, it's Mr. Chase again. Now I'm back inside my house, and I drew a little picture here to help us with what we were just working on. So the circumference of the tree was 46 inches. So the first thing I'm going to need to do is I'm going to need to find the diameter of the tree. Now the diameter is going to be the circumference divided by pi, and I'm going to use my calculator. If you want to just use 3.14, that's fine as well. Okay, so the diameter equals 46 divided by pi. okay? And let's see if I can bring up my calculator here. Calculator and pi buttons there. So 46 divided by pi equals, and I'm going to write down as much of this number as I can, maybe 3 or 4 digits. So 14.642, another 2. So I'll leave it like that, okay? So the diameter is roughly 14.642 inches. All right, and that's great, okay? Now, I also found this article, right? I found the video that you saw yesterday and an article that explained a little bit more about, step 1, how to estimate the tree by not cutting it down, right? That's the goal of this, is we're going to try to estimate how old a tree is by not cutting it down. Hopefully you're going to be able to find a tree near you. That's the lab that you're going to do tomorrow, and hopefully that will you'll be able to do that. But it says step 1, measure around the tree about 4.5, about 5 feet above the ground. Okay, so you're not reaching very high. You can do exactly what I did. Make it comfortable. Step 2, take that diameter, divide it by pi. We just did that here. Step 3, okay, determine the age of the tree by multiplying that diameter by the growth factor, okay? Now, there's a bunch of different trees here, okay? And if you don't know what kind of tree it is, which is totally fine with me, just go with what's in the middle here, which is about a 4. So use the scale factor, not the scale factor, use the growth factor of 4. I know that I was looking at a white oak tree, okay? A white oak tree, right? I looked it up. I looked at what the bark was and, kind of determined that. If you have leaves on the tree that you can look up and take a picture and try to find, what kind it is, that's fine. If you can't do that, just use the number 4 as your growth factor tomorrow, okay? And I'll say that again, but I'll take a picture of this, a screenshot, and make sure you have it as well so you can look at the different trees, okay? So I had a white oak, so my growth factor is actually going to be a 5, okay? A 5. Now, maybe it was a red oak, I don't know. Maybe it was a pin oak, I don't know. It was definitely an oak tree, and I'm going to go with a white oak, okay? All right, so now that's what I'm going to take. I'm taking my white oak number, 5.0, and I'm going to multiply it, okay, times my diameter. So I'm going to find the age. How old is this tree by doing diameter times, I'm going to do GF for growth factor, okay? So I'm doing 14.642 times 5, okay? 14.642 times 5, and that means, wow, the tree that I had to cut down because it was going to fall on my house was approximately 73 years old. Roughly 73 years old. Now, is that accurate? I don't know, okay? But what I do know is that I used math to be able to determine the age of a tree by finding its diameter through the circumference, multiplying it by its growth factor. Now, if let's say it wasn't necessarily a white oak, right? Let me go back to that article for a second. Let's just say it was I'll go with pin oak because a lot of the oaks look similar, right? If it's a pin oak, my growth number is only 3, right? So I would do 14.642 times 3, all right? I bring my calculator up again. 14.642 times 3. Okay. So maybe the age of the tree is only like 43 years old. Okay. Now, that's a big difference, and you know what? Maybe Dr. Williamson would know more about the scientific research behind this, but I'm going to guess, I'm going to say somewhere in between there, I'm going to say it's probably 60 years old from the math that we did, okay? That tree's old, okay? Old tree, all right? It's too bad it was supposed to fall down. It had to come down because, you know, it actually was pretty beautiful in my yard. But there you go, okay? Thanks for watching, all right? Probably have to post something in the discussion, so look for that today, all right? And I hope you guys enjoyed the video. Good to see you guys, and we'll talk to you soon, all right? Bye, guys.